Example, given a third degree polynomial function f of x equals negative 2 times x to the third power minus 8x squared plus 6x plus 36. Find the x-intercepts and their behavior. We're going to be referring to note 86, and specifically we're interested in the in-behavior portion, item number 4. Okay, we need to find the roots of this thing. Solution, find roots, because the roots are the same as finding the x-intercepts. So we're going to have to factor f of x, pull out the greatest common factor, which is negative 2, times what remains is x to the third power plus 4 times x to the second power minus 3x minus 18. Now that's a third degree polynomial we have to work on here. So let's try Descartes' rule of sign. No, let's use the, from the note that I just mentioned, note number 86, item number 2, the rational zero theorem. Rational zeros. If there are any irrational zeros, they will live in this list. P over Q equals plus or minus in the front. And don't forget to do that. That's very important. And then we're going to make a list on the top of factors of the last number in the x cubed plus 4x squared minus 3x minus 18. So the factors of 18 would be plus or minus, which is in the front, 1, and then we have 2, 3, not 4, because 4 times any whole number can't give you 18. Not same with 5, not 5, but we do have 6, and then we have jump all the way to 9, and finally we go to 18. On the bottom, we list the factors of the lead coefficient, the number multiplying the highest power of x. Well, there's an invisible 1 multiplying x cubed, so that's just plus or minus 1. And then when we take each of those numbers on the top and write them as a fraction over the bottom numbers, we get a list plus or minus the numbers 1, 2, 3, 6, 9, 18. Okay, now we're going to test the zeros. First we'll test r equals 1. Synthetically divide by 1 our polynomial that we have x cubed plus 4x squared minus 3x minus 18. The coefficients are 1, 4, negative 3, negative 18. And there's no missing coefficients, so we won't be putting the 0. Bring down the first number and then multiply. 1 times 1 equals 1. Add, you get 5. Multiply 1 times 5 is 5. Add, you get 2. Multiply 1 times 2 is 2. Add, you get negative 16. No, that doesn't help us. Let's go, because we're looking for a zero remainder, and we don't even get a bound at the bottom here, because we would have had to have all non-negative numbers at the bottom to say that we found the upper bound. Let's test r equals the next number on our list from the rational zero theorem. Let's try positive 2. We can try negative numbers too, but for now we're just going to go through this list, see what happens. It's pretty quick to do this. We got 1, 4, negative 3, 18. Negative 18. And we are looking for a zero remainder. Bring down the first number, 1. Multiply, 2 times 1 is 2. Add, you get 6. 2 times 6 is 12. Add, you get 9. 2 times 9 is 18. And then subtract, add, and you get 0. Yay! We found our root because we got a zero remainder. So this implies that our polynomial f of x which we already had factored a common factor of negative 2 out of, it leaves the following. X minus the root that we just found, 2, times, we're going to write out a polynomial 1 degree lower than x cubed, which is x to the second, using the numbers on the bottom line of that synthetic division. So it's 1 times x to the second plus 6 times x plus 9. Okay, so we need to just continue by factoring this number, and we can just do that by guessing. That equals negative 2 times x minus 2 times, factor by guessing, x plus 3 times x plus 3. Good. Now let's go ahead and write our answer in factored form with exponents if possible, which is possible in this example because we have 2 factors of x to the x plus 3. Okay, so according to that note that you have been sleeping with under your pillow for months, weeks, that tells us that we have the following x-intercepts. The first one is the ordered pair. The root is a number being subtracted, so it's a 2, 0. That's an x-intercept. And the other one is the number being subtracted from x is a negative 3, 0. And this one, 2, 0, had a power, the factorization had a power 1, which is odd power. So according to our note about in behavior, that means that 2, 0 is a cross. It crosses the x-intercept, the x-axis. While the factor for negative 3, x plus 3 squared, that was a multiplicity 2, even multiplicity. That means it doesn't cross, it kisses the x-axis. And those are our answers. All finished.